Welcome back, Honors Chem Stars. It's Ms. Macaulay. We're going to be going over Chapter 12 homework, page 8. Let's start with number 6. It says, a sample of oxalic acid, remember your acid naming rules, oxalic came from the 8 oxalate anion, so I ate something icky. So this is oxalate crisscrossed with hydrogen. Weighing 1.192 grams is placed in 100.0 mils of a volumetric flask, which is then filled to the mark on the neck with water. Remember, when we're filling volumetric flasks, they have a really skinny neck on them, and then there's a line that says that that's exactly where the 100 mils is. And what you're looking for is at the very bottom of the meniscus at eye level just comes in contact with that line. Okay, go back to your notes if you want to see more about how to prepare the solutions. Then it asks us, what's the molarity of the solution? So we know that M equals N over L. So the molarity of the solution will be equal to the number of moles divided by the volume. Okay, so we have to figure out number of moles. They're telling us 1.192 grams. We have to convert that to moles. So whenever you see grams, you should think periodic table. So H2C2O4, go to your periodic table, and here it is right here. We need 2 times the mass of hydrogen plus 2 times the mass of carbon plus 4 times the mass of oxygen. Add those all up, you should get 90.04. Okay, so I'm taking 1.192 grams, divide by the molar mass, and you get 0.01324 moles. I'm keeping, I need to have 4 sig figs at the end. I think that should be close enough. And then for my volume, remember we always have to go to liters, so we need to take the milliliters, cancel mils, go to liters. The other quick trick is, it's 1,000, that's 3 powers of 10. You can just hop your decimal point 3 places over, so 0.1 liters. Okay, so let's plug in and solve. So my number of moles is 0.01324, and then we need to divide that by our number of liters, which is 0.1000, getting all those sig figs. And then let's see what my final answer will be. Okay, well, for the sake of it, let's make sure I wrote down enough sig figs. 1.192 divided by 90.04. Okay, so there's a little bit more after that, but we'll keep that number in our calculator. And then divide by 0.1. So I get 0.132385 for the molarity. 0.132385. That's way too many sig figs. My units right here are moles per liter. Let's look back how many we actually need. 1, 2, 3, 4 sig figs. 1, 2, 3, 4 sig figs. So let's go. Okay, it's a placeholder. 1, 2, 3. Here's my 4th sig fig. Look to the right. That will round up. So we have 0.1324 molar. That's our final answer. Okay. Let's look at number 7. It says, describe how you would prepare 100 mils of a 0.025 molar sodium dichromate solution. How many grams of sodium dichromate should be added? Okay, so number 1, we need to find moles. So we need to find out how many moles there are. Okay, number 2, we need to calculate the grams. Number 3, we need to weigh out the sodium dichromate. Number 4, we're going to place it in a 100.0 milliliter volumetric flask. Then we're going to fill half with water. Halfway with water. Step number 5, you're going to cover and shake to dissolve. And then number 6, fill to line on the neck of the volumetric flask with the dropper. Now remember, when you look at a volumetric flask, we've got some pictures of the notes. There'll be an exact line right there that says 100.0 milliliters. And you're going to come in 1 drop of water at a time until you get the very bottom of the meniscus. So this one probably needs like 1 more drop. And we're looking for that meniscus at eye level to be just touching. So we have to add 1 more drop, and then we should hopefully get that correct volume. Okay, so here's all the steps. But then we've got to go through and actually do these things. Number 1, find the moles. Well, I know that M equals N over L. That means that N is equal to M times L. So M is 0.025 molar times 0.1000 liters. That makes my N equal to 0.0025 moles. I didn't use a calculator for that because look at my place value right here. I'm just 1 power of 10 smaller. Just make it 1 power of 10 smaller. If you need to, pull up your calculator. We're taking 0.025 times 0.1. We're going to get 0.0025, which we did in our head. That's how many moles we have. Now we've got to convert those moles to grams. Okay, that's an easy factor label problem. So we're going to have 0.0025 moles. Put that over 1. And then we want to get rid of moles and go to grams. Always put your units first, just like I taught you back in chapter 7.3. That's G for grams. 1 mole is how many grams? Okay, sodium dichromate. So you got to go to your periodic table. We're going to add up each of those numbers. Sodium dichromate. Oh, look at that. It's done for us. 261.98. So we're going to plop that number in here, 261.98. That's how many grams you need to make 1 mole. Take out your calculator, times 261.98. And it's going to be 0.65495. Okay, now that's how many grams we get theoretically, but how many are we actually going to be able to measure? Okay, we've got 1, 2, 3, 4 sig figs, but here there's only 2 sig figs. So it's kind of telling me that maybe my scale is only precise to 2. So here's my 2 sig figs. This is actually 0.65 grams. So here's what we do. Find the moles. We did that. Calculate grams. We're going to weigh out our sodium dichromate, which is actually 0.65 grams. You're going to put it in a flask, fill it halfway with water, cap it up, shake it to dissolve, and then the last step, get out your eyedropper and fill exactly to that line on the meniscus. And then you've done it. You have created 100 mils of a 0.025 molar sodium dichromate solution. Great work. Got 2 more problems on this page. I'll pause and do a new video for the next page of problems. Okay, number 8. Describe how you would prepare 2.50 times 10 to the second milliliters of 0.2 molar sodium sulfate. What mass in grams of sodium sulfate is needed? Okay, here's the easy part. These steps are all essentially the same. Okay, so describe how you prepare. You find the moles, you calculate the grams, you weigh out the grams, you place it in the right size volume. And then you fill it halfway with water and cap it. So what's going to change? It's going to be like what the compound is and the volume. Here it happens to be the exact same volume. So when it says describe how you can prepare, we're just going to refer back to that previous problem. Okay. So number 1, first thing is I have to find how many moles I need. Okay. I have volume. Now this one got a little funny. 2.50 times 10 to the second mils. Let's undo the scientific first. Okay, times 10 to the 2, it's positive, it's a big number. So 1, 2. That's actually 250 mils of the liquid. Why did they do 0.50 times 10 to the second? They were giving us the 3rd sig fig. See how there's only 3 sig figs here? They could have just done a period, but they want to make your life difficult. That's mils, but we want to go to liters. So then we've got to go back 1, 2, 3. 0.250 liters. Why didn't they just say that? I don't know. They want to keep you on your toes. So that is my liters. So liters equals that. And then they already told me molarity. So from the previous problem, we know M is N over L. And also that N, when we rearrange and solve, is M times L. So let's plug in our values here. M is 0.20 molar. L is 0.250 liters. So what's my value for N? M times L Oops, wow. That was too big. So 0.2 times 0.250, I get 0.05 moles. 0.05. Now, for sig figs, technically we need to have 3, so we'll say 500. And that's going to be how many moles of the sodium sulfate I have. Number 2, I need to convert those moles, 0.05000 moles of sodium sulfate, and I want to cancel out my moles, and I want to go to my grams. Okay, whenever you see grams, periodic table, sodium sulfate. And here it is. This is a magic periodic table, guys. Everything's already here. Sodium sulfate, 2 times sodium's mass plus 1 of sulfur's mass plus 4 of oxygen's mass gives us a molar mass of 142.05. So we're going to plop that number in here, 142.05 grams per mole. So 0.05 times 142.05, 7.1025. That's how many grams we need. 7.1025. Now, we have to double check how precise is our equipment. What did the problem tell us? Okay, here there's technically 3 sig figs. Here there's only 2. So I can only be precise to 2 sig figs. So I need to measure out 7.1 grams of the sodium sulfate. This is where I'm going to stop writing on this problem, but you should continue writing, please. Describe how you prepare it. All those steps. We found moles, we calculated grams. We're going to weigh out 7.1 grams of sodium sulfate. We're going to place it in a 100.0 milliliter volumetric flask. We'll fill it halfway with water. We'll cover it. We'll put a lid on it. We'll shake it to dissolve, and then we will fill to the line on the neck with a dropper, making sure we look at the meniscus. Okay? One last problem on this page, then we can take a break. Okay, the concentration of cholesterol that's in part of your normal blood is approximately 0.0050 molar. For fun, look, we got 2 sig figs there. Sig figs are fun. Describe how you prepare 750 mils, okay, now there's 3 sig figs there, of this solution. Well, describe how we would prepare. We already have done that a bunch of times, but we're going to go through and figure out what we need to know. Number 1, we need to find moles, okay? So we know that molarity is 0.050. We know that the volume, liters equals 750 milliliters. Well, we got to convert that to liters. So let's go 1, 2, 3, 0.750 liters. We're just solving for n again. So if m equals n over L, we want to isolate and solve. N equals m times L. Then we're just going to plug in what we know. So we know that we have 0.0050 molar solution. And instead of writing molar, let's actually write out what it is. It's moles over liters. So we can see that unit cancel out nice. And it's times 0.750 liters. So why did I do that? We've got a liter in the denominator. We've got a liter in the numerator. That leaves me with moles. See, it all works out. Okay. So 0.005 molar times 0.750 liters, 0.00375. Okay. 0.00375 moles. Now, I don't want to round this number yet. I know that I do only want 2 sig figs, but I'll round my grams. That way I'm not introducing any uncertainty into the problem. 2, I've got to convert grams or moles to grams. So I'm going to take this number 0.00375, 375 moles, put it over 1, and then we want to get rid of mole and go to grams. You got to go to your periodic table. I put the math in right here. So 27 times carbon's mass, C27, 46 times hydrogen mass, that's H46, plus 1 oxygen. Remember, if there is no number here, it's implied to be a 1. The molar mass of cholesterol is 386.73. So 386.73 grams per mole. We've got that moles saved in our calculator times 386.73 and I'm going to get 1.450. 1.450 grams. Now, remember that we can only have, how many sig figs were in the original part of the problem? We can only have 2 sig figs. So 1, 2, 5 is going to round that up. We need 1.5 grams of cholesterol. Okay, same thing here. Pretend this says cholesterol. I'm not going to go through and describe how you prepare. You need to, though, summarize those 6 steps. Those are important. So we found out the moles. We know that we need 0.00375 moles. We convert that to grams. We need 1.5 grams of cholesterol. How do we make the dissolution? We measure that into the volumetric flask. We fill it halfway with water. We cover it, we shake it to dissolve, and then we fill up to that 750 line using an eyedropper to get that very last drop so that the meniscus is at eye level, just touching that line. Okay, that's the end of our page 8. Come back for the next video and we will go over page 9. Great work today, guys. Bye.